Evrenin işleyişinde bir hassas ayar var mıdır? Bu Tanrı'ya işaret eder mi?
Is there a fine-tuning functioning of the universe? Does this point to God?
So first, the background is, what is the anthropic range? So there's been this argument or scientific discovery, it's been ongoing, for about 60 years now, is that the universe itself has to be structured in very precise ways in order for life to occur. And that's not just the laws of nature, that like the mathematical rules nature behave according to which nature functions, but also the initial conditions of the universe. And then a primary focus has been on the fundamental parameters of physics. Fundamental parameters are just numbers that have to go in to physics equations. So a couple of examples is something that's near fundamental, not quite, is the mass of the proton. So, or the mass of the neutron, or the mass of the electron. Those are examples, or the strength of gravity as given by Newton's constant. G determines how strong on any given planet with a certain mass gravity will be. So that's, people have noticed those have to be enormously precise in order for life to occur. And so, estimates are those are like 1 part in a billion, 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 billion. And you can say that for an hour or so. That's how precise we're talking about. So that was what's called the anthropic fine-tuning argument for God. It was considered that very unlikely under a non-theistic point of view that a universe that was so precise as ours would exist. But if given that there's some value in the existence of beings like us, then it's not super improbable under a theistic hypothesis that God exists that these values would be so precise. Now, the common atheist response to that, especially among physicists and cosmologists who've thought about it, is the multiverse hypothesis. And what they say is that given there's enough universes, that some physical process that generates them, and these values of the constants, for example, vary from universe to universe, then eventually there'll be a universe that is just right for life to exist. And of course, then we will evolve on it and we'll look back and say, aren't we lucky? But the idea is we couldn't have existed in any other kind of universe. So it's neither improbable if there's enough universes that there's variations in their parameters that one of them would be just right for life. And it's not improbable that life or observers like us arise, we're going to see it very fine-tuned because we couldn't have existed in any other kind of universe. So they'll claim there's no improbability there because it's done away with by this multiverse hypothesis. Now, one response to that is the universe generator for the multiverse itself would have to be very well, what I call a universe generator, the physical process that gives rise to the multiverse, would itself have to be very fine-tuned in order for life to exist. Okay, so that's the background on the standard anthropic fine-tuning argument. And the anthropic range is just the range that allows for life, and it's subject to this multiverse objection. Now comes in the fine-tuning for scientific discovery. So people had noticed that the universe was set for discovery at the level of the laws of nature. So Albert Einstein, one of the most famous physicists, or probably the most famous physicist of the 20th century, said that the most miraculous thing about the universe is that it's intelligible at all. And Eugene Wigner, one of the major founders of quantum mechanics, the fundamental physical theory we have today, said that it was a miracle that mathematics works so well in discovering the nature of the universe. So both of them recognized there was something really special about how the universe was structured for scientific discovery. What no one had done, though, is quantify that. So what I did, starting back in 2010, I asked myself the question, well, what if you take one of these fundamental parameters like the strength of gravity or the mass of the proton and changed it, just like they did for the fine-tuning of life? What would happen to our ability to discover the universe, particularly our instruments of discoverability? And if it was fine-tuned for discovery, you would expect just a slight shift in those would cause the universe to become less discoverable. So they would be set to optimize discoverability. Well, I started looking at some of the fundamental parameters and seeing if that was the case. So the first one I looked at was what's called the fine structure constant, which determines the strength of the electromagnetic force, which is what's behind radio waves, heat radiation like emitted from fires. And what I found is that it was in this very small range, such that if you increased it by a little bit, not too much, you couldn't have open wood fires. And so human beings wouldn't have ever smelt, or very unlikely they would have smelted metals and forged metals. And so you wouldn't have had science at all. And if it was smaller, there'd be much more chance of forest fires, the resolving power of like microscopes would be less, so on and so forth. So that was one of the first cases I discovered of this fine tuning. And then I looked for other cases. The second case was what's called cosmic microwave background radiation. And there's a fundamental physical parameter called the matter to photon ratio, and it stays pretty much the same during the universe as the universe expands. And it affects the cosmic microwave background radiation. Now, the cosmic microwave background radiation is the fundamental tool used to discover the large-scale structure of the universe. In other words, it's the fundamental tool for cosmology. And so the stronger it is within limits, the better it's going to be as a tool for discovery. So when I actually calculated how that depended on this matter to photon ratio, what I found is that the matter to photon ratio over this huge range was set just right. So it maximized that cosmic microwave background radiation. So it maximized our ability to use that as a tool. So I sent it to several physicists I knew, and so they verified the results that was correct. And so that was the second big case. Then I looked at a lot of other cases, but I wanted something as definitive as that. So then I went into particle physics. And particle physics, we're all familiar with, I hope the audience is, the structure of an atom is consisting of protons, neutrons, and electrons. And then the protons and neutrons are composed of what they call quarks, up and down quarks in particular. But for the up quark and the down quark, there is two heavier sisters of it. So for the up quark, there's a heavier version of it called the charm quark, which is more massive, and then an even much heavier version, which is about over about 200,000 or 100,000 times as heavy, called the top quark. And likewise for the down quark, same thing. Those are called generations. And then for the electron, there's a heavier version of it called the muon, and then the tau lepton, and then there's the Higgs boson. So that's basically the way the standard model, and those particles are part of what they call the standard model of particle physics, are considered the basic components. So I went and looked at those and to see if those, especially the second and third generation, like the muon or tau lepton, what would happen if you varied those for our ability to discover things, particularly in particle physics. And those within a wide range don't have any anthropic effects. So that was the advantage of looking at those. You could do pure discoverability effects. And once again, it seemed to be highly fine-tuned for scientific discovery. I'm completing that project now. So, getting all the physical details, but worked out. But many of the cases have already run by other physicists. So what it looks like is there's a fine-tuning there of about 1 part in 100 trillion over and above. When you combine that with the cosmic microwave background radiation over and above the anthropic range. So given that, the big thing about these is they can't be explained by a multiverse hypothesis, because the key to the multiverse explanation was that we couldn't have existed in any other universe than one that was fine-tuned for life. Because if it's not fine-tuned for life, we couldn't have, the conditions wouldn't have been right for our existence. But that's not true for the case of scientific discovery. If this fine-tuning is the case and the constants were just produced by random, as in the multiverse hypothesis, then you would expect the vast majority of universes that give rise to beings like us would not be optimal for scientific discovery. And so the fact that we find it optimal, not just that we can discover the constants, but that they're optimal for doing science, that becomes super improbable just on the random hypothesis. But on the theistic hypothesis, if you think that there's some good to be realized of these constants having the values that that there's some good about science being successful. In other words, that God wanted us to be able to do science and discover the universe. Then it's not unlikely under theism, because theism says that God is perfectly good. So if something's good, that gives God a reason to bring it about. So that's the core argument. Now, why would you think that this was good? And the reason you would think, there's many reasons you would think this was good, but one thing is that if you think from a theistic perspective, it's in the very heart of what is often used to run against theism, or kind of what they call the paradigm of rationality, of rational methods of finding things out, science, put into there just the way the universe is structured, that the very success of that points beyond itself to somebody behind it. So that's one reason. And so it's God has put a pointer to God's self within the heart of science, and that would make sense that God would do that. So and I think that would be a good. Another reason is technology helps us with, we can use it for good things. So it's set for the development of technology. And there's several other reasons I could give, but those are just indications of some of the reasons. And so if that's right, then it's, like you said, there's a scientific discovery. It's highly improbable under naturalism, even under a multiverse hypothesis, which seems the only possibility to explain the fine-tuning for life from a naturalistic perspective, but it doesn't do that for scientific discovery. So the scientific discovery, no matter what the naturalist says here, it's very improbable under naturalism that there'd be this fine-tuning, not improbable under theism, because there's goods realized by the fine-tuning for scientific discovery, only a couple of which I mentioned. There's quite a few more you could cite. Goods of having the success of science and our ability to recognize that it's fine-tuned for that. So it's not improbable under theism. And then you just use Bayesian confirmation theory, which is standard, that it offers strong evidence for theism over naturalism.